Again, I'm going to model the first order systems, but a special class of first order system. So write the topic that is called, first of all topic लिख लेते हैं कि करना क्या है ना, then इसको शुरू से start करेंगे. Linearization of non-linear models. Non-linear models. Okay. ये क्या आ गया बीच में? We were discussing disturbance models. I mean disturbance, process and response. Disturbance खत्म हुआ, process चल रहा था. Process में मैंने आपको बताया कि if the system modeling gives you first order differential equation, then it is first order system. If it gives you second order differential equation, then it is second order system. Then from where this came, linearization of non-linear models. So the question is, what is a non-linear model? When you model a system, modeling के बारे में सारी जानकारी दे चुका हूँ. Now when you model a system, you are getting a differential equation. This dynamics is a lot similar to differential equations, right? Differential equation की order के बारे में आपको पता है. If differential equations are having some order, the system is also having order. You also know that there is a differential equation is also categorized as linear and non-linear. And from there only we have non-linear models. Suppose if you model a particular system and the differential equation obtained after modeling the system is non-linear, then the system is called non-linear model, right? However, it can be first order, can be second order. Order का linearity और non-linearity से कोई लेना देना नहीं है. We can have linear first order differential equation, non-linear first order differential equation, correct? Linear second order differential equation, non-linear second order something like that. तो linearity अलग चीज है, order अलग चीज है, दोनों में confuse नहीं होना है. Fine? दोनों का basis अलग अलग है. So we are right now talking about linearization of non-linear first order models, right? So write down the definition first. A system whose modeling gives a non-linear different. Now you know modeling, so I'm not writing those things. A system which can be explained or which can be represented, whose behavior can be represented, वो सब नहीं लिख रहा. A system, I can also write like this, a system whose dynamics can be explained. Okay, so a system whose modeling gives a non-linear differential equation, a non-linear differential equation is called a non-linear model. Non-linear model. Because I'm talking about first order system only. Now you may ask me that, sir, first order system and non-linear model, I mean non-linear system, can they occur simultaneously? Yes, because these two are based on a different basis, right? Okay, just like bound moisture and free moisture. Like bound, unbound and free. Can bound moisture be free moisture? Yes, it can be. So if they are based on different bases, they can occur simultaneously. Similarly, linear and non-linear and first order and second order, they are based on different bases. Now the question arises, what is a linear differential equation? कई बार आप differential equation भी पढ़ लेते हो, फिर भी आपको ये clear नहीं होता. What is a linear differential equation? Linear पता होगा तो non-linear अपने आप पता लग जाएगा. What is a linear differential equation? A differential equation in which the dependent variable, you know dependent variable, if I write dx by dt, x is the dependent variable. If I write dy by dx, y is the dependent variable. If I write dt by dx, t is the dependent variable. So the numerator wala is the dependent, denominator wala is independent. A de in which the dependent variable and its derivatives, dependent variable and its derivatives occur in first degree only. First degree. Degree means power. I'm not talking about order of derivative. Order की बात कर लोगे तो वो तो order की definition हो जाएगी. A differential equation, order of a differential equation is defined according to what is the power of its, power नहीं कहेंगे, what is the order of derivative, the maximum order of the derivative. I mean it is second derivative, third derivative, like that. But linearity, non-linearity is defined that in which the dependent variable and its derivative occur in first degree only. And and they are not multiplied together, and they, डिफरेंशियल इक्वेशन में आपको पढ़ाऊंगा, मैं ही पढ़ाऊंगा, है ना, and they are not multiplied together. ठीक है, means you can say that a differential equation is linear only when the differential, suppose I am saying the dependent variable will be y. In most of our case, dependent is y. So y, the power of y should always be 1. The power of dy by dx, either it is dy by dx or it is d square y by dx square or it is d cube y by dx cube, its degree, its power should always be 1. There should be no multiplication of dependent, and I mean y and dy by dx should never be multiplied. X and dy by dx, they can be multiplied, right? So this is the condition for a differential equation to be linear. If any of this condition is not followed, the differential equation is not linear. Fine, right? So when you model a system, when you get this kind of equation, then only it is a linear system. What about the order? I told you it depends upon the order of the derivatives. Now you can see if all the previous models, you can check again, go back again and see that in all the previous model, what is the nature of the differential equation. You will find that all of them are first order and all of them are linear also. Y was not having power other than 1, and there was no multiplication of y and dy by dx. But if there is a non-linear model, then what we do, now this was the definition of a non-linear system. Now what is linearization? Right now, non-linear models can be approximated as linear models. How? I'll tell you. Non-linear models can be approximated. मतलब मैं non-linear की modeling करूंगा, approximation करके उसे linear मान लूंगा. This process is called linearization. We are modeling a non-linear system and approximating its behavior as a linear system also. Non-linear models can be approximated as linear models, which is called linearization. Okay. I'll tell you how. Suppose we have a graph between y and x. There is a relation. Y, which is some function of x. Okay. Suppose we have this kind of graph. Some random kind of graph. Now you tell me the relation between y and x. Is it linear? The relation between y and x, is it linear? What do you see here? Definitely it is not linear. Y is not a linear function of x. So, okay. The relation between y and x is not linear. Now what I am going to do, let's say that at this point, at some point, let us call that this point as some value of x, and at the same way, this is the value of y. At this point, which is having some coordinate, let's call it x-axis and y-axis, right? At this point, if you make a tangent, I'm making a tangent here. Okay, I was able to make a straight line. Okay, fine. No, अब टेढ़ी होनी शुरू हो गई है ना? Okay, एक बार जो बन गई सो बन गई. This was a tangent at this point. If you see the tangent and the curve, if you see this much area, if you see at least this much, it totally depends upon my choice, your choice. But if you see at least this much, don't you see that there is not much difference between the value given by this line and the actual value of the curve? The curve gives you actual value and the line gives you approximate value. Only in this region, not beyond this region. Beyond this region, there is a significant gap between the graph. ये मैंने ऐसे ऊपर कर दिया, इसको seriously मत, चलो इसको छोड़ो, इसको ऐसे कर लो, because of course it can be that also, but ऐसा कुछ कर लेते हैं, ठीक है? Now, if you see only this region, you can see that in the given region, the answer given by this line and the answer given by the graph are not very different. But beyond that, there will be possibility of significant error, right? What is this? This is error actually. This is error. But that can be ignored here. What I can assume that this graph is almost equal to this green line in this region. This is called linearization. Assuming that a non-linear function is behaving like a linear function is called linearization. Now you may ask, sir, मैं तो यहाँ तक मान लूँगा. Now that totally depends upon how much error you can tolerate in the predictions. क्योंकि देखो, अगर आपने approximation, आपने suppose यहाँ तक करा, तो मॉडल जो बनेगा वो अप्रोक्सीमेट बनेगा. मॉडल का जो रिजल्ट आएगा वो अप्रोक्सीमेट बने, वो भी रिजल्ट अप्रोक्सीमेट आएगा. उस हिसाब से आप सिस्टम को कंट्रोल करोगे, हो सकता है कंट्रोल भी अप्रोक्सीमेट आए. तो मॉडल आपको बताता है ना, मॉडल टेल्स यू द बिहेवियर ऑफ द सिस्टम. पर अगर मॉडल ही गलत है तो बिहेवियर भी गलत आएगा, तो कंट्रोल भी गलत होगा. सो दैट्स व्हाई आई एम सेइंग हाउ मच एरर यू कैन टॉलरेट. डिपेंडिंग अपॉन दैट you can say that okay, under this region also it is linear, or sometimes you may say no, I can't even tolerate this much error, only this much, only under, I mean inside this region I'll assume that this curve is linear. This thing is called linearization. Totally depends that in which region it is actually linear. I mean, okay, that depends upon toleration limit. Now if I ask you that can you write the equation of this line? What is the equation of this line? What is the equation? What is the equation? So linearization is basically approximation of the real model. मतलब मॉडल अपने आप में ही अप्रोक्सीमेशन है. लीनियराइज करके आपने उसको और अप्रोक्सीमेट कर दिया. मॉडल जब बनाते तो वैसी assumptions ले रखी है हमने, तो मॉडल वैसे ही पूरी तरह एक्यूरेट नहीं है, पर आपने लीनियराइज करके उसको और लेस एक्यूरेट बनाया, राइट? So linearized model is not exact model of the process. So its outcome, its answer, its response will also not be exact. Okay? But this is the process. Again, you may ask, फिर sir क्यों कर रहे हो? It is the process of simplifying the things, simplifying the discussion. Right? What is the equation of this line? This green line, है ना? कैसे लिखोगे? You know that this line is passing through a point y minus y-ss is equal to slope of the line x minus xs. ऐसे लिखते हैं ना? When you know that a line is passing through a point, this is how I write the equation line. What is the slope of this line? Can I say that the slope of this line is dy by dx? I mean y versus x relation is this. I can write dy by dx, but you'll see that the dy by dx value here, the dy by dx value here, the dy by dx value here, dy by dx value everywhere it is different. Which dy by dx? The dy by dx at the point xss comma yss. xss comma yss. बन गई लाइन की इक्वेशन, right? So what is the equation of the line? Y is equal to yss plus dy by dx at xss comma yss multiplied by x minus xss. Clear? This is called linearization. You have assumed that the function of y and x is now linear. Earlier it was non-linear, it's now linear, but please note it is approximate model, and this is the same thing which is given by Taylor's series. Taylor's expansion. Taylor's expansion. क्या है Taylor's expansion? A function y of x can be expanded about some point xss comma yss as yss plus y is equal to yss. Y is a function of x, some function of x. So what is the meaning of yss? The value of y calculated at x is equal to xss plus dy by dx at x is equal to xss comma yss, xss and yss, x minus xss, right, plus d square y by dx square at xss comma yss. I'm not writing yss, you can if you want, x minus xss whole square plus higher order terms. Of course, this is the Taylor's expansion, right? But I want to linearize the system. How I can use this one? I cannot use this because this will become x square. Again, it will be non-linear. So only up to this will be used in case of Taylor expansion, and this equation are nothing but the same. This is the explanation. This kai baar main Taylor's expansion batata bhi nahi, only this is the thing, right? So whenever you have a non-linear function that can be approximated as a linear function, as a linear relation, and then I can model the system, right? Now, can you tell me any example of a non-linear function? For example, y is equal to, suppose I have this kind of equation, y is equal to 1 by h. Is it linear? No, it is not linear. You can see the graph also. Bhai 1 by x ka graph pata hai, right? It's not linear. Y is equal to root h. Is it linear? No. Y is equal to ca square. Is it linear? Y is equal to sin x. Y is equal to, all of them can be approximated as a linear relation. Fine. Of course, that model will not be very accurate. So I can approximate them as a linear relation. How? 1 by h is equal to 1 by hss plus dy by dh. I mean, see, y is a function of h here, so I will differentiate with respect to h, not with respect to x. So what is the dy by dh? What is the relation of 1 by h? That is, what is differentiation of 1 by h? I think minus 1 by h square, right? And dy by dh at h is equal to hss multiplied by h minus hss. That, because you see that hss is not a variable, it is a constant. Differentiation sahi likhi hai na? Yes, it is a constant. This is a constant. So this is a linear relation. This is how I can approximate 1 by h, which was a non-linear relation. Similarly, you can see here root h. Root h will be root hss plus differentiation of this, that is 2 root h. Sorry, 1 by 2 root h. 1 by 2 root h, and then again add the value of ss multiplied by h minus hss. Linearized. Ca square is equal to cass square plus 2cass ca minus cass. Linearized. Like this, you can linearize any non-linear relation. What about y is equal to x? X is a linear relation. The power is 1. So whenever you model a system and when you have a non-linear differential equation, there will be a term in that differential equation which is causing non-linearity. पूरा differential equation non-linear, हर एक term non-linear हो ऐसा जरूरी नहीं है. It is possible that in that differential equation there will be a term which is causing non-linearity. That can be of any nature: root, square, reciprocal, sine, cos, e raised to power x. That can be expanded by using this Taylor's expansion, or you can say that this concept. This was the concept of linearization. Now I am going to take few examples. Actually, I will be taking 3 models. So 2 models I am going to solve in this lecture, the non-linear models. And rest one I will give you for homework that you have to try कि आप उसकी modeling कर पाए थे कि नहीं कर पाए. Fine. And slowly we are going to the end of the discussion of this process model for the first order system. Okay. So when this modeling part is complete, then we can talk about the response of a first order system. I told you that first order system are most important for you. ठीक है? So note कर लो, है ना? मैं किनारे हो जाता हूँ so that एक बार आप pause करके वीडियो नोट कर लो, अगर नहीं किया है तो ठीक है, and then मिटाते हैं इसको. So we were talking about linearization. Now I gave you, I think we discussed 4 models, right? This will be the 5th model, and let us see कि इसकी modeling कैसे करते हैं. Now I'm going to take again a liquid level system. Fine. Liquid level system modeling will be done. Everything is same. The output variable, input variable, the function of time, everything, nothing is going to change. The only thing that changes here in this system is now the relationship between Q out and height of the system is not linear. This is a very common standard question for practice of gate, right? So I think this was 5th model. Fine, that is liquid level system. Liquid level system. Now I'm not going to talk about those lumping of parameters. वो आप जानते हो. Liquid level system with non-linear resistance. You know what is the meaning of non-linear resistance? Fine. Suppose this is the liquid level system. Cross-section area A, density constant, process is isothermal, Qn, which is a function of time. This is liquid level, height at a given point, which is a function of time. Valve. Now this is the problem. This thing has changed here. We'll talk about this. And Q out, which is also a function of time. I'm not writing any assumptions. The assumptions are same as before. The only thing which has changed is here the relation between Q out and height of the liquid level in the tank is non-linear. Now you may ask कि sir non-linear relation कैसा होता है? Non-linear relation की एक ही बात खासियत है that the power of H will not be equal to 1 and this is something like Q out is equal to some constant C, can be any number, okay, root H. Now wait, is non-linear relation, is it necessary that non-linear relation will always be root H? No. It can be anything, can be 1 by 2, can be 1 by 4, can be H raised to the power minus 1, can be anything. I am just taking an example where the flow rate is related with the height of the liquid level in the form of a square root power. So I will be deriving the result with respect to this relation. But please note that non-linear relation between Q and H can have any kind of form. It can be general form I am giving you, and I'll also give you the result for this general form. General form is equal to Q out is equal to C into H raised to the power 1 by N, right? N is more than 1, 1 by 2, 1 by 3, 1 by 4, that kind of relation. This is 1 by 2. So I will be deriving for this. Rest, everything is same. The input output variable, nothing has changed. The assumption is not changed. What is your job? Your job is to write unsteady state balance. Now what is changing here? Total mass, component mass, temperature, momentum, what is changing here? Velocity, what is changing? You are going to say that the mass is changing and that to the total mass. So I will write unsteady state total mass balance. Unsteady state total mass balance. ठीक है? लिखता है total mass balance. Same thing. Rho is constant. Q in into rho minus Q out into rho. जल्दी जल्दी लिख लो, कुछ इसमें समझाने वाला नहीं है. Is equal to d by dt of area into height into rho. Rho gets cancelled and you have this equation Q in minus Q out is equal to A dH by dt. Now Q out has this relation, so I will write Q in minus C root H. You may ask कि सर अभी आपने ऐसा क्यों कर दिया, आपने पिछली बार तो बाद में पुट किया था. Doesn't matter. In the last discussion, I had discussed that how we can decide the output variable. That is why I did this step after writing the deviation variable. You can do here as well. After writing the deviation variable, you can do this. Doesn't matter. कोई फर्क नहीं पड़ेगा उससे, ठीक है? Okay, this was the equation. Because right now I know that I want to relate H and Q. That is why I know already. इससे पहले मुझे बताना था कि I want to relate H and Q or I want to relate Q out and Q. Here I am sure that I want to relate H and Q and therefore I directly wrote Q in minus C root H is equal to A dH by dt. ठीक है? Fine. So क्या करें आगे? We will write the steady state equation, that is Q in SS minus C root HSS is equal to A dHSS by dt. Obviously, this relation will also be valid at steady state. So Q in SS, okay, Q out SS is equal to, yeah, and definitely at steady state Q in SS and Q out SS will be equal. Not a problem. Okay, so this is the equation. Now let us write this in the form of deviation variable. Fine, and that deviation variable will be Q out, ठीक है, Q in minus Q in SS, all the steps are set, minus यहाँ पे भी कर सकते हैं, that's what I was thinking, चलो कोई बात नहीं, C root h minus root hss is equal to a d h by dt. I mean h minus hs by dt को लिख दिया adh by dt. Can I write you may get confused actually if I do this step. एक काम करते हैं, थोड़ा सा यहीं पे लीनियराइज कर देते हैं. वाई कर सकते हो बाद में, बट मैथमेटिकली थोड़ा सा करेक्ट नहीं होगा, इसलिए मैं ऐसे नहीं कर रहा. डोंट वरी. यहां तक ठीक था. आई रोट दिस. इज दिस अ डिफरेंशियल इक्वेशन? What is the order of this differential equation? 1, right? First order differential equation. Is this a linear differential equation? Write down. Above differential equation is a non-linear differential equation. Is a non-linear differential equation. Why? Because the dependent variable power is not equal to 1. The non-linearity is caused due to root h. आप बोलोगे सर प्रॉब्लम क्या है? रहने दो ना, नॉन लीनियर, कोई दिक्कत नहीं है, ऐसे ही सॉल्व कर लेते हैं. Why to convert it into linear? The thing is, I don't know how to solve a non-linear differential equation. I don't know how to take the Laplace of this. How I'm going to write the transfer function? I have to convert this into the linear form. Now, what is linear form? I will write this equation as, this is non-linear, so now I will write the equation as in the form of q in ss minus c root h ss is equal to a d h ss by dt. Now we will subtract it, so the equation will be q in minus q in ss minus c into root h minus root h ss is equal to a d h minus h ss by dt. चलेगा, कोई दिक्कत तो नहीं है. Now, right now, I will not be writing the deviation variable. I will first replace this. Fine. See how. You know that, shortly I told you that previously in the discussion of Taylor's, this is equal to root h ss plus 1 by 2 root h ss h minus hs. ये समझ आया? ठीक है? Can I write from here that root of h minus root of ss is equal to 1 by 2 root h ss h minus hs. ये समझ आया? मैं गलती ये कह रहा था कि इसको रूट ऑफ कैपिटल एच लिखना ज्यादा सही नहीं होगा. दैट इज वाई आई अगेन केम बैक टू दिस स्टेप. कोई ज्यादा फर्क नहीं पड़ा, बट ठीक है, थोड़ा मैथमेटिकली मुझे सही लग रहा है डिराइव करने में. ओके, सो बाय यूजिंग दिस टेलर एक्सपेंशन आई कैन रिप्लेस दिस टर्म विद 1 by 2 root of h ss multiplied by h minus hs. Now everything is fine. Now, whatever difficulty was there due to the non-linear term, now that has been removed. फटाफट कर लो इसको. डेविएशन वेरिएबल क्या आ जाएगा? ये h. ओके, इज इक्वल टू a dh by dt. स्टैंडर्ड फॉर्म में लिखते हैं a dh by dt प्लस c by 2 root h ss, h is constant, not a problem here, प्लस is equal to qn. इसका कोफिशिएंट 1 बनाना है. कैसे 1 बनाएंगे? बाय डिवाइडिंग दिस. सो dh by dt a डिवाइडेड बाय, एवरीथिंग इज फाइन. ओके, a डिवाइडेड बाय c 2 root hs. ओके फाइन. ओके चलो लिख लेते हैं 2ca डिवाइडेड बाय c डिवाइडेड बाय 2 root hs. ऐसा ही कुछ है ना? हाँ, 2 root hs प्लस h इज इक्वल टू qn डिवाइडेड बाय c बाय 2 root h ss. ये चलेगा. दैट इज द इक्वेशन. कैन यू राइट द ट्रांसफर फंक्शन? प्लीज ट्राई बाय योरसेल्फ. Try by yourself, write the transfer function h by q. What will be the transfer function? H bar s, q in bar s, h bar s, q in bar s. What is kp? Kp is 1 by c by 2 root hs. So kp will be 2 root h ss by c. Kp. What is tau p? 2 रूट एच एस एस बाई सी, ये ऊपर चला जाएगा, मल्टीप्लाइड बाई ए. सो 2 रूट एच एस एस बाई सी मल्टीप्लाइड बाई ए, दिस मल्टीप्लाइड बाई एस प्लस 1. करेक्ट आ गया? ठीक है. यू कैन कंपेयर दिस दैट दिस मॉडल एंड द फर्स्ट ऑर्डर मॉडल आर सेम. तो ये भी फर्स्ट ऑर्डर है तो मॉडल तो सेम होना ही था. दिस इज ऑल्सो फर्स्ट ऑर्डर. आई हैव नॉट अज्यूम्ड दैट इट इज फर्स्ट ऑर्डर, इट इज ऑलरेडी फर्स्ट ऑर्डर. बट व्हाट वाज द अजम्पशन, व्हाट वाज द अप्रोक्सीमेशन? इट वाज नॉन लीनियर. और जब मैंने रूट एच को ऐसे अप्रोक्सीमेट कर लिया, नाउ इट हैज बिकम द अप्रोक्सीमेशन. नाउ इट इज द लीनियराइजेशन ऑफ अ नॉन लीनियर मॉडल. राइट? नाउ स्टिल डिस्कशन इज लेफ्ट रिगार्डिंग दिस. ये तो ट्रांसफर फंक्शन आ गया. नाउ कैन आई कंपेयर इट विद द लीनियर मॉडल विद व्हिच आई हैव डिस्कस्ड few moments back in the previous lecture? Okay, so if we compare this model with the linear liquid level system model, write down, if we compare this model with the linear, मतलब इससे जो पहले किया था, linear liquid level system. If we compare this model with the linear liquid level system, then डायनेमिक्स देखो भाई, डायनेमिक्स में ज्यादा समय नहीं लगाएंगे, लेकिन पढ़ेंगे तो पूरा डीप. समय लगेगा थोड़ा सा कंट्रोल में, टॉपिक्स ज्यादा है. ठीक है, पर आप देखोगे कि आप खुद से ना चीजों को रिलेट कर पाओगे. यहाँ पे डायनेमिक्स में काफी आसान सा सब्जेक्ट है. मास ट्रांसफर जैसा, सीआरई जैसा लंबा नहीं होना है ना. सीआरई एमटी ऑलरेडी पोर्टल पे आप लोग को मैंने 2 सब्जेक्ट्स करा दिए. वो जो 2 सब्जेक्ट्स हैं, दे आर अप्रोक्सीमेटली इक्वल टू 3-4 सब्जेक्ट्स. बड़े सब्जेक्ट्स है. जब बड़े सब्जेक्ट कंप्लीट होते हैं तो मेरा भी प्रेशर कम होता है, आपका भी प्रेशर कम होगा. दैट इज वाई पहले मैंने सीआरई एमटी कराया. अभी देखो, अभी गेट का नोटिफिकेशन है. नाउ जो थोड़ा सा लूज बैठे थे, जो थोड़ा रिलैक्स होके बैठे थे, नाउ दे आर इन अ हरी. अब जल्दी में प्रिपेयर करेंगे, और फिर जल्दी का काम कैसा होता है आपको पता है. कोई बात नहीं, आपको 2 महीने लगे, 2 महीने में 2 ही सब्जेक्ट हुए, पर ऐसे 2 सब्जेक्ट हुए. ऐसा नहीं कि आपको मैंने एप्टी और मैथ करा दिया 2 महीने में. नहीं, वो सब तो फटाफट कराएंगे. क्योंकि भाई देखो, कुछ चीजों का तो आपको पता है. एप्टी में इंग्लिश के आप 250 वर्ड याद कर लो या 2500 वर्ड याद कर लो. आपने 2500 वर्ड याद किए, 2501 वाला वर्ड आ जाएगा. नो वन कैन डू एनीथिंग. दैट इज ऑल अबाउट चांस. ठीक है, लेकिन वो चांस से कोई बहुत बड़ा डिफरेंस नहीं आने वाला. उस चांस से आप +1 -1 जाओगे, +2 जाओगे, वो आप टेक्निकल में मैनेज कर सकते हो. तो टेक्निकल में ऐसा नहीं कि कुछ ऐसा पूछ लेगा, एक आधा पूछेगा. बाकी तो ये सारा जो मेजोरिटी है, और मतलब ये जो आपको डिस्कशन दे रहा हूं, इस डिस्कशन से आपका 90% के ऊपर पेपर आएगा. ठीक है, 1-2 क्वेश्चन आएंगे, शायद आप उसको रिलेट ना कर पाओ, या 1-2 क्वेश्चन ऐसे आ सकते हैं जो कोई नई बात भी पूछ सकते हैं. आई एम नॉट डिनाइंग दैट फैक्ट. डेफिनेटली पूछ सकते हैं. हर बार ऐसा नहीं होता, बट हो सकता है. लेकिन कुछ चीजें ऐसी हैं जिनके पीछे आप कितनी भी मेहनत कर लो, उसमें पूरे नंबर ला पाना बहुत. एप्टी में देखो 15 मार्क्स लाते हैं स्टूडेंट्स, ऐसी बात नहीं, ले आते हैं. समटाइम्स इंग्लिश के क्वेश्चन आसान आ जाते हैं, समटाइम्स ग्रामेटिकल एरर वाले क्वेश्चन आसान आ जाते हैं. एप्टी में 10 नंबर से ऊपर तो देखो आना ही चाहिए. अदरवाइज एप्टी कैन बी द डिसाइडिंग फैक्टर. अगर आप 10 से भी कम नंबर ला रहे हो, देन एप्टी कैन बी डिसाइडिंग फैक्टर. सम स्टूडेंट्स आर स्कोरिंग ओनली 2 और 3 मार्क्स इन एप्टी. 2-3 नंबर ला रहे, नाउ वो वहां पे डिसाइडिंग हो जाएगा. बट यू शुड बी हैविंग अ प्रैक्टिस. आप थोड़ा तो लेके चलो कि यार कुछ एक आधे वर्ड्स इंग्लिश के मुझे हो सकता है याद ना हो, तो पॉसिबली -1 -2 तो होगा ही. 10 के ऊपर तो लाना है एप्टी में. टेक्निकल में अपन ऐसा करेंगे कि कुछ बचेगा ही नहीं. ठीक है, एप्टी में भी यही करेंगे. बट ऐसा हो जाता है कई बार कि आप इंग्लिश में कहीं इधर उधर रह जाते हो. इंग्लिश भी करेंगे, लेकिन क्योंकि देखो इंग्लिश तो लिटरेचर है भाई, लिटरेचर में कुछ भी पूछा जा सकता है ना. ठीक है, सो यहां पे वो सारा डिफरेंस हमें मैनेज करना है टेक्निकल में. ये टेक्निकल से कुछ नहीं छोड़ना है, कुछ नहीं बचेगा यहाँ पे. ठीक है, इफ वी कंपेयर दिस मॉडल विद द लीनियर लिक्विड लेवल सिस्टम, then we can say that, see, you can compare this one, then this will be the KP. What was the model of that system? याद है? Okay. Then can I say that R resistance is equal to 2 root HSS by C. ये कहने में कुछ गलती तो नहीं है. देखो, compare R divided by A into R into S plus 1. If you compare this with the linear system, then resistance is equal to 2 root HS by C. ये करेक्ट है. ओके, नाउ आई एम गोइंग टू गिव यू वन कंक्लूजन. इससे देखो किसी कंक्लूजन तक पहुंचते हैं. फाइन, राइट, मिटाते हैं इसको. ठीक है, दिस वाज वन लीनियर मॉडल. और ये बहुत स्टैंडर्ड डिस्कशन है. ये तो डिस्कशन नॉन लीनियर में करते ही करते हैं. आपको मैं एक और एग्जांपल ले लूंगा बस. दिस डिस्कशन इज ऑलवेज डन. ये क्वेश्चन आते हैं इस पर. ठीक है, सी दिस वाज द रेजिस्टेंस. नाउ लेट अस कम बैक टू द स्टोरी. वी वर हैविंग दिस रिलेशन दैट Q out is equal to C root H. Clear? Can you tell me what is Q out dash? Dash means okay, derivative. ये वो वाला dash नहीं है. This is Q dash means derivative. That is C by 2 root H. Can you tell me what is the value of Q dash out at SS? That is C by 2 root H SS. Can you tell me what is the reciprocal of Q out dash? Dash means derivative. I'm repeatedly saying at steady state that becomes 2 root H SS by C. और यही तो resistance है. Fine. So can I say that R can be found directly from here? So using this analogy, if the transfer function, using this analogy, if the transfer function, not the transfer function, if the relation of Q out and H is, suppose if the relation is not Q out is equal to C root H, but it is something like C H raised to the power 1 by n, where n is suppose 3, it is 1 by 3. Then what you are going to do? Same thing, and you will be obtaining something. But you can save some time here. अच्छा, एक बात बताओ. Suppose if I give you the value of R, can you write the transfer function? Because the transfer function will be R by A. In A तो A रहेगा. The transfer function will be R by A into R by S plus 1. It means if I just give you the value of R, you can directly write the transfer function, and R can found like this. So if this is the relation between Q and H, then R you can directly write that R is equal to the reciprocal of derivative of Q out, which is calculated at H is equal to HSS. Once you calculate the value of R and then directly write the transfer function. वो सब करने की जरूरत नहीं है. बहुत ज्यादा टाइम नहीं लगा उसमें, बट ज्यादा उसको करने की जरूरत नहीं है. ठीक है, दिस इज द रिलेशन टू फाइंड द वैल्यू ऑफ R and directly write the transfer function if this kind of Q out is equal to CH raised to power 1 by n kind of question is there. Now, this question was, I think it came in 2019, where there were 2 tanks connected in series. Now, if you use this formula in that question will be solved within seconds. Okay. Otherwise, if you derive like this for each and every time there were 2 tanks, then it will take 2 minutes, 3 minutes, maybe 5 minutes. Okay. So this was one more model. That was the 5th model. It was a non-linear model. ठीक है, आगे बढ़ते हैं. I am going to take one more model that is non-linear and you are going to linearize it for me. ठीक है, linearize करेंगे and we'll try to obtain the linear model. See, first non-linear का मतलब second order नहीं होता, ध्यान रहे. First order ही चल रहा है, क्योंकि linear non-linear तो basis ही अलग है ना. तो मैंने non-linear कह दिया तो आप बोलोगे सर ये तो second order हो गया. ऐसा नहीं है. ठीक है, ये छोटी छोटी कंफ्यूजन्स हैं जिससे बाद में क्वेश्चंस गलत होते हैं. एंड मैंने आपको पहले बताया क्वेश्चंस हम लोग रिस्पॉन्स पढ़ने के बाद ही ले सकते हैं. ठीक है, सो सेकंड वन. ओके, दिस वाज सिक्स्थ मॉडल. concentration dynamics means I will write mole balance on A of perfectly stirred, concentration dynamics of perfectly stirred constant hold up, perfectly stirred constant hold up, concentration dynamics of perfectly stirred constant hold up. और क्या, isothermal reactor पहले कर चुके हम, but earlier it was a first order reaction, now it is second order reaction. Where second order liquid phase reaction is taking place. Second order liquid phase. Okay, previous derivation you have to remember. I mean the result you have to remember. This one no need to remember. It's fine. It's just for your understanding. Liquid phase reaction is taking place. So again, I will not tell you about the assumption. It is isothermal, constant volume. So Q in is equal to Q out. No need to write the total mass balance is taking place. आगे बढ़ते हैं. Reactor है. What is coming in? Q. What about the output volumetric flow rate? Of course Q, because it is constant hold up. It is Ca naught, which is a function of time. This is Ca, just like the previous question. Volume is constant. A giving B reaction is taking place, and minus R is equal to Kca square. Can you write the balance? वीडियो स्टॉप करो, बैलेंस लिखो, देखो लिख पाते हो कि नहीं. अगर ये लिख पाए तो ठीक है, थोड़ा कुछ समझ आया आपको. ठीक है. Now, what is the A which is getting in? Q Ca naught. What is A out? QCA. What is the reaction? Minus Kca square into V is equal to d by dt of Ca. This is perfectly mixed, okay? Perfectly mixed means this concentration and this concentration are same. d by dt of VCA. बिल्कुल वैसे ही किया यार, इसमें अब दोबारा समझाने लायक मुझे नहीं लगता कुछ है. Okay, now I will write the equation at steady state. So QCA naught SS minus QCA SS minus KCA SS square V is equal to d by dt VCA SS. Clear? Subtract करो. Q CA naught minus CA SS. ठीक है? Same scenario. Minus Q, everything is same as before. The only one thing that is going to change is this one. Minus KV CA square minus CASS square. See, this equation is linear or non-linear? Again, this equation is non-linear, and non-linearity is caused by this term because this is the dependent variable and its degree is not equal to 1, right? So, देख लेते हैं. Minus KV CA square, ठीक है, is equal to V d CA minus CASS by dt. Fine. Now where is the problem? In this problem is present in the CA square term. So CA square term को कैसे लिख लेंगे? CA square is equal to CASS square plus 2CASS multiplied by CA minus CASS. This is how you linearize the thing, and therefore what is the result for CA square minus CASS square? That is equal to 2CASS CA minus CASS. ये वैल्यू यहां पुट कर लो. करेक्ट? बहुत जल्दी कर सकते हो यार, इसमें कुछ नहीं है. Q CA naught minus CA naught SS. Q CA naught minus CA naught SS minus Q CA minus CASS minus KV. So KV and this value is, इसको 2 यहां लिख देते हैं एंड CASS यहां लिख देते हैं. ठीक है? Okay, I'm sorry. This should be CASS square. 2KV CSS CA minus CASS is equal to V d by dt CA minus CASS. ठीक है? चलेगा? है ना? Now चीजों को कॉमन ले सकते हैं, लेते हैं. देखिए, Q CA नॉट डैश डिविजन वेरिएबल माइनस Q प्लस 2KV CASS CA minus CSS Q CSS plus okay, CA minus CSS means CA dash is equal to V dCA dash by dt. I think my calculations are correct. Minus CA dash. ठीक है. Now you will write this equation in the standard form. V dCA dash by dt plus CA dash Q plus 2. Now this is linear. This is linear, right? 2KV CASS 2KV CSS or is equal to Q CA naught dash. समझ आया? What is the now? What has to be done? The coefficient of this has to be made unity. For this, I will divide the equation. Now I think you can write the transfer function. dCA by dt V by dCA by dCA dash by dt V divided by Q plus 2KV CASS. Q plus 2kV CaSS, right? And then plus Ca dash is equal to Q divided by Q plus 2kV CaSS. ठीक है क्या? कुछ गलती हो गई? नहीं, ठीक है, इक्वल टू एंड मल्टीप्लाइड बाय Ca नॉट डैश। याद नहीं रखना है भाई, ये सब चीजें याद रखने वाली नहीं है, ये तो बस अंडरस्टैंडिंग के लिए है कि मॉडलिंग कर पा रहे हैं कि नहीं कर पा रहे, लिनियराइजेशन कर पा रहे हैं कि नहीं कर पा रहे। और वहीं एक एग्जांपल बता के छोड़ दूंगा तो बस आपकी सोच वहीं तक रह जाएगी। थोड़ा सा आगे बढ़ते हैं। इफ दिस काइंड ऑफ नॉन linearity is there, then how you are going to deal with this? Now can I say that in this case the transfer function will be Ca dash bar s divided by Ca naught dash bar s. What is Kp? Kp tau p. So Kp was is equal to Q divided by कुछ वैसा ही है लेकिन चीजें थोड़ी सी चेंज हो गई यहां पे, 2kV CaSS Q by, last time it was Q by Q plus kV, okay, and V divided by Q plus 2kV CaSS divided by S plus 1. ठीक है, अगेन अ लीनियराइज्ड मॉडल ऑफ अ नॉन लीनियर फर्स्ट ऑर्डर सिस्टम। इस तरह से अगर आपके पास नॉन लीनियर के और भी केसेस आते हैं, देखो नॉन लीनियरिटी कैन बी कॉज्ड ड्यू टू एनी रीजन। Here it was caused due to the presence of Ca square term, which was due to the order of the reaction. In the previous case, it was caused due to the presence of root H term, which was due to the non-linear relation between the outlet flow rate and the liquid level. Fine. So, see, मैं पहले ही बताता जा रहा हूँ कि अब ये रटने मत बैठ जाना, फिर बोलो सर पीडीसी बहुत मुश्किल पढ़ा दिया आपने, कुछ याद नहीं रह रहा। जो रटना है वो मैंने अलग से लिखवा दिया है। अब ये सब नहीं रटना है, लेकिन हाँ मॉडलिंग करने का जो पूरा प्रोसेस, अगर प्रोसेस रटा है तो कम से कम ये सारे 4 पॉइंट्स याद हो गए। बस उसमें आपको ट्रांसफर फंक्शन याद रखना है मरकरी इन ग्लास थर्मामीटर का। देन यू हैव टू रिमेंबर द ट्रांसफर फंक्शन ऑफ दैट लिक्विड लेवल सिस्टम। फर्स्ट ऑर्डर CSTR you can remember, not a problem. Then after that you have to remember the transfer function of the liquid level system which is containing non-linear resistance. So this was the 6th model. I am going to take a 7th model as well. ठीक है, यहां कोई परेशानी ना रहे, ठीक है। So that is माई ऑब्जेक्टिव। 7वां मॉडल लेते हैं, ठीक है। तो डायनामिक्स पार्ट में ज्यादा टाइम नहीं लेंगे, ठीक है। फर्स्ट ऑर्डर के बाद मॉडलिंग में एटलीस्ट और टाइम नहीं लेंगे, ज्यादा मॉडल डिस्कस करने की जरूरत नहीं है। द नेम ऑफ द सब्जेक्ट इज प्रोसेस डायनामिक्स एंड कंट्रोल, नॉट मॉडलिंग एंड सिमुलेशन, राइट। थर्ड पार्ट, आई टोल्ड यू दैट आई विल गिव यू दिस एज योर होमवर्क, है ना। कुछ थोड़ा सोचना इस पर। There is this triangular tank. No one takes this problem in process dynamics. कई बार बच्चे बोलते हैं कि सर ये करना जरूरी है क्या, इतनी मुश्किल प्रॉब्लम आएगी क्या? I don't think कि इतनी प्रॉब्लम मुश्किल आ सकती है, राइट। लेकिन थोड़ा सा प्रोसेस डायनामिक्स को थोड़ा सा और थोड़ा लिनियराइजेशन की प्रैक्टिस हो जाएगी, थोड़ा सा डेरिवेशन की प्रैक्टिस हो जाएगी। रटना तो कुछ नहीं है इसमें, नथिंग टू लर्न, राइट। क्यों? There is this कई बार बच्चे ऐसे प्रॉब्लम देखे कई बार खुश हो जाते हैं, फिर वो ज्यादा साइंटिस्ट बनते हैं, फिर वो मेरे पास अलग अलग प्रॉब्लम ले आते हैं। वो भी करना जरूरी नहीं है, देखो, है ना। दिस इज अ कोनिकल टैंक, ओके, कोनिकल टैंक, राइट। द लिक्विड इज कमिंग फ्रॉम हियर, द हाइट ऑफ द टैंक is equal to H, capital H, which is fixed, है ना। हाइट तो टैंक की हाइट फिक्स्ड। The diameter of the tank is equal to capital T, and the liquid is leaving from here. There is a valve, and yes, this valve is again non-linear. This is Q out. The relation between Q out and the liquid level inside the tank. Now, please note the liquid level inside the tank is changing, है ना। Capital H is not changing, but this height will obviously it will change if there is change in Q or there is change in this, right? Q out is related to this height as C root h. Non-linear relation. Rest assumptions, density constant, isothermal. What you have to find? You have to find the liquid level dynamics. You have to find the transfer function h bar s divided by आप Q in कह लीजिए उसको, then you have to find Q in bar S. कर लोगे क्या? मुश्किल, ज्यादा मुश्किल नहीं, थोड़ा सा ट्रिकी है ना. And yes, let me tell you that in dynamics, don't do the problems given in any course books. I mean the books that are followed in semesters, because dynamics इतनी एक तो पूछी नहीं जाएगी, but dynamics को डिटेल में मैं इसलिए बता रहा हूँ so that control we can understand. ऐसा नहीं कि अब आप फिर उसमें अलग अलग टैंक्स के शेप ले और बोलो सर इसका निकालो इसका निकालो, दैट विल बी अ कंप्लीट वेस्ट ऑफ टाइम, राइट. दिस इज जस्ट फॉर योर फन. आप ट्राई करो इफ यू आर एबल टू डिराइव दिस ट्रांसफर फंक्शन और नॉट. विद दिस द मॉडलिंग ऑफ फर्स्ट ऑर्डर सिस्टम गेट्स कंप्लीटेड. आई एम नॉट गोइंग टू डिस्कस एनी मोर मॉडल्स हियर, राइट. व्हाट वी आर गोइंग टू डिस्कस आफ्टर दिस इज द रिस्पॉन्स आउटपुट ऑफ फर्स्ट ऑर्डर सिस्टम. हो सका तो नेक्स्ट क्लास में इसको डिस्कस कर लेंगे, ठीक है. So response of a first order system that we will discuss, then we will move to the higher order system. So that was all for this class.